This example comes out of section 11.1, permutations. In this first little bit, I want to explain what this means. Now, this is something that you probably haven't run into in math before. It's an exclamation mark, and it doesn't just mean a really loud number 5. In class, I always startle everybody by screaming the number 5 when I write this on the board, and it gets a couple people to jump. But what 5 with an exclamation mark really means, the way you say it in math is 5 factorial, and it means 5 times 4 times 3 times 2 times 1. If you multiply that all out, you get 120. But what we have here is something called factorial notation. So even right on the Math 30 formula sheet, you'll see something about factorial notation that says if you've got n factorial, that you start off with n, you multiply it by n minus 1, n minus 2, n minus 3, n minus 4, etc., all the way down until you get to 3 times 2 times 1. As long as n has to be a natural number, meaning that there's no decimals, no fractions, no negative numbers, etc. And by definition, 0 factorial is equal to 1. And your calculator will even tell you that. Your formula sheet will tell you that. And as we get later on into some permutation questions, you'll see why 0 factorial needs to equal 1. But so, if you want to try this on your calculator, you press the math button, go over to the what's called the PRB menu, and you'll find down there, I believe it's option number 4, you'll find the exclamation mark. So you can try 6 factorial and see what it equals. And you press 6 factorial, enter, and it'll tell you 720. And that's because what your calculator did was 6 times 5 times 4 times 3 times 2 times 1. So you can imagine that these numbers get pretty big pretty fast. Your calculator can't handle it once you get past 70 factorial. It says digit overflow, because your calculator can only do, if you're doing a Texas Instruments thing, numbers up to times 10 to the 99. So these numbers get huge fast. You can do 69 factorial, but you can't do 70 factorial. So just to illustrate uses of factorial notation, I asked 2 questions, but they're really the same question. How many ways could we seat 5 students in a row? Or how many arrangements of all the letters in UNITS units? Either way, we have 1, 2, 3, 4, 5 spaces. We have 5 objects for the first, then 4, then 3, then 2, then 1. If we realized that right away, we would have just said 5 factorial equals, and we know that from above, it to be 120. The answer to either one of those questions would be 120. So the next question we've got, how many ways can a 7-person committee select a president, a vice president, and a treasurer? We're given no reason to assume any one of these 7 people can't be the president, vice president, treasurer. So one way to do this, again, would be to say, I've got 3 spaces to fill. 7 people could go into that first space, leaving me 6 for the next space, leaving me 5 for the next. So 7 times 6 times 5 equals 210 ways that those positions can be filled. We find out that we end up doing this a lot, doing basically part of what would have been 7 factorial. 7 factorial, as we see up above, would have been 7 times 6 times 5 times 4 times 3 times 2 times 1, but we only have 7 times 6 times 5. What we have here is called a permutation. If we look at this as 7p3, a way of reading that is 7 arrange 3. We have 7 objects. We want to arrange 3 of them. Your calculator will do this again under that same math PRB menu. You'll find the NPR notation. What it actually does is it does 7 factorial over 7 minus 3 factorial. So 7 factorial over 4 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 4 times 3 times 2 times 1. Now, lots of that cancels out. You end up with just 7 times 6 times 5, which is 210, which is the answer to this question. But the P notation, NPR, as it says on your formula sheet, is n factorial divided by n minus r factorial. This is if we're arranging, meaning that the order matters. We have n objects altogether, and we're arranging r of those objects. So in this case we had 7 people and we were arranging 3 of them. The reason why the order mattered was because if I make you the president, that's different than if I make you the treasurer or vice president or whatever. So if we would have just said how many ways can we select a committee of 3 out of 7, we would do that differently, and we'll run into that in the next section. But in this case, order matters. If order matters and you have n objects and you want to arrange r of those objects, you do npr. Again, in the math menu, go over to PRB, and you'll find NPR. On your calculator, it would look like 7 NPR 3. And when you hit enter, it'll tell you that that answer is 210.